Here's a quick review on protons, neutrons, electrons, just atomic structure of an atom. Hopefully you kind of know this stuff. We won't spend much time on it. Remember the nucleus of an atom, which is very, very small. Very, very small. Contains the protons, which have a positive charge and weigh 1 atomic mass unit approximately. Contains the neutrons, which have no charge or neutral and weigh approximately 1 atomic mass unit or 1 AMU. So these both weigh about 1 AMU, which is a really, really, really small unit of measure. It's really just a way to compare one atom to another in terms of size. So with 1 proton, 1 neutron, this element would have a mass of 2 AMUs. Electrons are in the electron cloud moving around the atom three-dimensionally. The electron cloud would be 10,000 times bigger than the nucleus. So the nucleus is where all the mass is at, or all the weight. Electrons are moving on the outside. Electrons are negative, have essentially no mass, or very, very small mass. Atomic number is right here. Tells you the number of protons. So boron has an atomic number 5, carbon number 6, so it has 6 protons, and if it's neutral, 6 electrons. The mass number is an average of all the isotopes of that element. It's average mass of all the isotopes of that element. Let's get a little closer. So, if we were drawing an atom of boron, boron would have 5 positive charges, 5 protons in the nucleus. That's what the atomic number is telling you. And 5 electrons moving around the outside in an electron cloud in some specific paths, but they'd be moving around there, speed of light. That's if it's neutral. Now, it normally has a +3 charge, which means it normally only has 2 electrons. It normally has lost 3 electrons. Cannot gain or lose protons or neutrons. Those are stuck in the nucleus. Mass number, we round to the nearest whole number. At least the most common isotope would have a mass of 11. 11 minus 5 is 6. Most common isotope has 6 neutrons. Again, these two add up to the atomic mass right there. So atomic number, mass number, this is protons, it's also electrons. This is protons plus neutrons, at least for its most common isotope in there. All right, looking at your stuff in your notes here. Cobalt 60 is telling you, no, that's supposed to say strontium, but cobalt 60, this is the mass number, okay? Not the most common isotope of cobalt. Most common isotope of cobalt is actually cobalt 59, if you look on your periodic table. So this is a certain isotope that has a mass of 60. So you find cobalt on your periodic table. Cobalt is element number 27. It means it's got 27 protons, 27 electrons because it is neutral, has no charge on it, whereas this has a charge, And 60 minus 27 is 33. That's the number of neutrons. Protons and neutrons added together is a mass number. This is supposed to say strontium, okay, not SL, strontium 90 and Te 128. I'll let you do those. Let's say we have vanadium with a positive 3 charge. So if I have vanadium in the periodic table, and it is element number 23, so it's got 23 protons. That never changes. Every element would have that for vanadium. Its mass number is 50.9, so 51, and it has a positive 3 charge. So normally 23 protons, 23 electrons if it's neutral. If its charge is positive 3, it means it's lost 3 electrons. So it's got 20 electrons. Mass number, like I said, is 51. 51 minus atomic number is 28 neutrons. All right. Selenium. Selenium is element number 34. So it has 34 protons. Charge is -2, which means it's gained 2 electrons. So instead of having 34 electrons, it now has 36. It's got 2 more electrons than it has protons. And mass number of selenium is 79 on the periodic table. 79 minus 34, 45. It's got 45 neutrons. Again, mass number is protons plus neutrons. All right. 7 diatomics, have no fear of ice cold beer. You got hydrogen, and then from nitrogen to iodine in the periodic table, fluorine, chlorine, bromine, iodine. Those are diatomics. Remember, those elements that always occur in pairs when they're by themselves. There's only those 7. Every other element, like calcium, if it's by itself, is just Ca. Potassium by itself is just K. But these 7 elements always occur in pairs when